Edition of Believe in Serverless, and we're going to talk today about ECS and blue green and safe deploys with Fargate. So feel free to jump into the conversation and say hello and ask questions, and off we're going to go. So let me see if I get my screen shared here. So I'm going to go ahead and start. We're going to do a little bit of presentation, and then we're going to mix it in with some live coding as well, which should be a ton of fun. So hang on. Still kind of a newbie at this, but let's see. I'm going to go ahead and share. Oops. Let's start with that. So, all right. So let's go ahead and get started. So safe deployments with ECS and blue green with CodeDeploy. So why in the world would we want to do this? Well, we're going to talk about some strategies for being able to deploy with ECS and specifically with Fargate and using CodeDeploy as our deployment controller, which will give us things like Canary and blue green and all kinds of safety that we desire for. So bear with me. I'm still getting my StreamYard foo down. So, hey, if you're new or if you don't know who I am, I'm Benjamen Pyle, easier to call me Ben. I've been in the industry for quite some time. So I'm a 25-year veteran. I've been an engineer. I've been a CTO, all kinds of things. I'm a big fan of serverless first. You might have seen some recent writing about that. I'm a big fan of trying to stay serverless if I can, and then pivoting where I need to for things that make more sense to always run a kind of continuous mode. So, which is what we'll look at today with containers. I like things compiled over interpreted. That doesn't mean I don't like interpreted things. You'll see a little bit of code that is interpreted and both compiled today. So a mixture of both. I'm an AWS community builder. So familiar with that program. It's an AWS sponsored program. And I'm in the serverless category, but I tend to bounce all over. And then I'm co-founder of a consultancy called Pyle Cloud Technologies with my wife. We focus on AWS cloud consulting and cost optimization. So you can find me on the socials there on the left. Any of those places are totally fine. So we're going to get into deployment. So I want to walk you through just a little bit of just background, and maybe it's a little basic, but it gives us a place to start from and a shared understanding of where we are. And then we'll dive into a few deeper concepts and then ultimately get to a live demo. So deployments, right? So if you're going to be shipping code out to the cloud, these are my three definitions that are three categories that I've seen over my career. There's probably a couple of more, but I think most everything will fall into one of these or another. And so we'll call them the recreate strategy, the mix in with live, and we'll have the blue green strategy, which we'll ultimately get into. And that's going to cover all at once, linear and canary, if that's which ultimately we're trying to save those canaries as we were talking about in the demo. So recreate deployment, what is that? Well, a recreate deployment is essentially something that's going to require an outage, right? You're going to have this version of your software that's out there, and let's call it version 1. And then we're going to want to install version 2. So what do? Well, we take everything offline and we basically shut everything down, and then we bring up new code, and then we wait for new code to get healthy. And so this entire process, while things are going on, the system's essentially unavailable. And the user is seeing all of this pain and frustration, right? Or they've got some kind of a banner that says, hey, we've gone fishing, come back later, something along those lines. So recreate deployments have been around for a long time. It's what you do when you schedule a maintenance window. If you've ever had your bank call you and say, hey, we're going to be down from Saturday from 2 p.m. to 4 p.m. They're doing a recreate deployment. They're not going live with code. They're having to shut things off and bring things back up, right? So user is burdened by this and is forced to wait until all of that code is completed. So second strategy that is super common, and this is probably where a lot of people live in the cloud, is in this mix in with live strategy. And what does that mean? Well, kind of contrary to the recreate strategy where users are suffering through not having their application up, mix in with live brings up both new code and old code up at the same time, right? So you technically are going to experience no downtime, but you've got version A and version B that are both sitting out there and running at the same time. So let's say that you have version A, then you have version B, and you've introduced a bug in version B. Well, some percentage of your users are going to experience that bug because the way that load balancers work and the way that the traffic's going to be split, you may get 10% or 50% or whatever it is that's going to be experiencing those defects, right? The beauty of mixing in with live, though, is that it's simple. You can just do a deployment, put some new tasks out there, attach it into your load balancer, and off you go. Right? Extremely simple, but again, at the risk of contaminating your current live production code. Third strategy that is, like I said, but super common and becoming more easier by the day, which we'll look at with CodeDeploy here in a little bit, is the blue-green strategy, right? So under blue-green, if you remember from the beginning of the talk, you've got the all at once, we've got a linear, and we've got a canary strategy, right? So all at once sounds a lot like what you would think it would sound like. And the way that it works is it's very similar to the mix-in strategy. But what will happen is that the new containers or the new tasks will come up, and then when those are live, then all of the old tasks are pretty much instantly shut down, right? So you're still exposing yourself to the problem of having bad code in B, but you're not really being mixing about it, right? You're going to have problems with B, and everybody's going to get all those problems because you're routing traffic and you're moving things over, and A pretty much goes away, right? So, but however, it is a little bit safer from the standpoint that the exposure, right? It's a greater exposure than with mixing them in live all at one time. So launch new code, switch all at once, which is the way the term describes, and then off you go when you're running. Well, when doing this with CodeDeploy, one of the nice things, and this is an option that we'll look at, you do get the ability to do some testing and play with some traffic shifting before it all goes over. You get the ability to hammer on those things, and then you also could set up some rollback on conditions. So if for some reason you had new tasks were experiencing 10% of errors and you wanted to roll back when that error threshold was greater than 5%, then that's something you absolutely could do. And so you get a little more safety with anything under the blue-green umbrella because you're able to then shift backwards to what you had. So we'll look at what CodeDeploy does and the way that you can hang on to tasks so that if you do encounter some defects that you can roll back pretty quickly. And so you do it risk exposing all of your problems at once, right? With all at once is obviously in the name. So everything's going to move to traffic in one direction. But again, you do have the safety built in that you can roll back if you need to pretty quickly. So all at once is what I would describe as the least safe of all of the blue-green strategies. And so next up, what we're going to look at is canary deployments. And so when people think of blue-green, they probably think mostly of canaries, right? And so our goal is to save those canaries and make sure that we don't have any damage or harm to those yellow birds. But what the canary strategy is, it's more of a cautious version of blue-green. And what do I mean by that? Well, unlike the all at once, right, which if you shift all 100% of your traffic at once and expose your users to 100% of the bad code, canary is a little bit safer from the standpoint that it goes in two phases. Phase one is you shift a percentage of your traffic, and then you're going to wait for a period of time, right? So the way it works is I'm going to say, let's say 20% of our traffic or 10% of our traffic in this case, in number of minutes. So, a really good default might be we're going to put 10% of our traffic over the next 10 minutes is going to get code B while code A stays live. So 90% is going to code A and 10% is going to code B. And during that window of time that you would like to have held open, you can run automation, you can run watch alarms, you can use CloudWatch. So your users are live hitting both sets of traffic, but your blast radius is much smaller. So if I'm encountering errors, only 10% of my user base is going to see those errors, right? And so you've limited the number of people that might get exposed to something bad. And so two things can happen from there. One is you can encounter some errors or you can encounter something you don't like, and which will automatically trigger a rollback, right? So then all of the 10% of B would just roll back into A. And off you go. Or you reach the 10-minute window or whatever the window was, and all of the traffic then just automatically shifts over. So if you were 10% over or 20% over 10 minutes, the balance of that traffic will shift at 10 minutes and 1 second, which is kind of nice because you've proven some duration of time that you feel good about. Again, with code deploy, which we'll look at, you've got testability before you shift traffic. There's a handful of hooks that code deploy gives us access to that we can take advantage of to be able to test and automate this. So just like the all at once, we can test traffic before, but unlike the all at once, we can protect ourselves by sending some canaries out into the world, and hopefully they survive and we go live with our traffic. Next up is the last pattern, and probably the safest and most cautious pattern that code deploy supports, which we'll call it the blue-green linear. Looks like a stair stringer. They're going up atop of it, but it's the same principle and the fact that it is blue-green. And again, we're going to look at what that means here in a minute on some live code. But the way it works is this: just like with the all at once, I've got blue and I've got green. I've got service A and I've got service B. Service B, though, gets deployed very similar to how Canary does. But what you do is you break the deployment up into percentages over windows of time. And let's say that you want to shift 25% of your traffic every 15 minutes, which means that your deployment would take a full hour to complete 100%, right? So the way it works is it's going to shift however many you say and however often you tell it to shift it, and code deploy will take care of transitioning that traffic out through the environment. So again, it's the most cautious because if I want to shift 10% every 10 minutes, like I was doing with my Canary, it's going to take me 100 minutes to shift all that traffic, and I can watch at different points. And at any time during that deployment, I can roll back, right? I can roll back manually. I can roll back due to error. I can roll back kind of automatically based on some CloudWatch alarms. And so it's the safest version because with Canary, remember, you would only shift twice, the initial shift and then the shift at the first block. But with blue-green linear, you're shifting in increments that you like as safely or as aggressively as you want to go. And again, you've got testability built in. So before you even begin the blue-green deployment process, which we'll look at, you can do some testing. So automation is super important when looking at any kind of blue-green strategy or any kind of deployment strategy in general. And not to mean that if you're not automating your deployments, I would encourage you to quickly start to look into how you could do that, right? But AWS provides several solutions for achieving this right out of the box. We're going to look at one pattern. There are many patterns, right? You can use Route 53. You can use load balancers. You can use other options, auto scaling groups, and all sorts of things. But we're going to look at code deploy, and code deploy gives us access to two blue-green strategies, or actually three. You get the all at once, Canary, and linear. And it's got support for two compute options, which I think are pretty cool because you can get ECS with Fargate or EC2, and then you also have access to Lambda. So if you've not experienced blue-green Lambdas, it's a whole nother level because you Lambdas are subject to failure just like containers are. But we often don't think about deploying Lambdas in blue-green, but code deploy supports both of those compute options, and it's pretty fantastic. So, but today we're going to look at ECS and code deploy and go from there. So what does our architecture look like in a blue-green scenario? What we're going to build is an API gateway that has access to a load balancer. Then that application load balancer is going to have a target group for our service. It's going to have a blue and a green. And then we're going to set this up in a way that we can deploy out to that ECS cluster with Fargate in a container that I've already built and that we'll take a peek at. And then you can route traffic, or the code deploy will manage the traffic routing. And the way it's going to work is as the deploy happens on whatever frequent or whatever style we do with all at once, Canary, or linear, it's essentially going to manage the traffic weighting on the load balancer target groups. So all we've really got to do is give it a specification and tell it what task we want. And code deploy is going to take care of migrating between blue or green. And blue or green doesn't really matter. Just essentially is one hot, one cold. You can call them whatever you want, but blue green is the pretty standard pattern. So Blue Green with ECS, like we've talked, it supports it with CodeDeploy. CodeDeploy manages traffic shifting. We're going to have a deployment strategy, which is going to be linear or Canary, and we'll probably do a Canary one. Traffic is again managed by that load balancer target group, which we'll take a look at. And the load balancer rules are forwarded onto that target group based on whatever we set up. And there is, just as a call out, there is a 100 target group max on a load balancer. And so if you think about Blue Green, you could put 49 services underneath because you're going to need 2 target groups for each service that you deploy out and code deploy. And so what does that look like when we kind of tie it all together? This is what we're going to look at from the UI standpoint. CodeDeploy is available either visually or CLI. We're going to look at it visually today. We're not going to CLI our way to deployments, but it's a pretty easy step to run the AWS CLI to run CodeDeploy, and we get a nice visual, right, with history and traffic and logs and all that good stuff that we want to have attached to CodeDeploy. If you've not used it before, it's a pretty fantastic service. And then we've got hooks that we can take advantage of that we're going to look at as well. And those hooks are lifecycle hooks, essentially. And so in CodeDeploy, you have Lambda functions that you can build, and then you can execute at any point, either before install, after allow traffic, before allow traffic, or after allow traffic. And we'll kind of play around with before allow traffic. And so think about it this way. We'll look at it, but it's really more of what kind of automation can you run before you even let live traffic roll out to your environment? It just kind of becomes an additional check that you could build in from an integration testing standpoint. So CloudWatch metrics, super important. Won't look at those, but just we'll give you some guidance to kind of look further. They can trigger rollback on alarms. So if you want to pay attention to a target group or a load balancer and look for 500 errors, or you want to look for latency or whatever it is that you may have, you can absolutely do that. Another interesting approach would be you could monitor your SLOs, so your service level objectives, through Datadog or through some other tool, right? And then you could turn around and execute the CLI through some kind of a webhook to be able to do things. So there's lots of ways to do it. The AWS native way is to go the CloudWatch metrics. CodeDeploy can be scheduled, right? So let's say that your change advisory board meeting happens on Tuesday and you want to deploy on Thursday. You can schedule up to 2 days in advance, or actually 1 day and 23 hours and 59 minutes, so essentially 2 days, and then available by CLI or script, so you can run those however you want. And then targets can remain. So let's say you do a Blue Green deployment and everything was successful and your old targets are still hanging around. So your deployment is sitting in a suspended state until it isn't, right? It can sit suspended for up to 2 days. And what that means is that, like, let's say that you deploy on a Tuesday and Wednesday morning, you find out that somebody else deployed something and you have this bug and your version doesn't work with their version, and you want to be able to roll back quickly. Well, instead of forcing a redeploy of an old version, you could simply just go hit stop deployment and it'll roll back all that code and shift all that traffic back for you. So that'll hang around for up to 2 days if you like. All right, so let's get into a live demo. I can't see my screen, so hopefully I can figure out if any questions so far. Let's see. Anybody jump on? Any questions? I'm looking at myself. So no. Cool. I'm going to go over here. Looks like Andres might have been private chatting with me. All right. I got a second monitor, Andres, just in case you were wondering. So. All right, so let's take a peek at what we've got here. I want to kind of start off with what do we have so far? And so let's look at what do we have, project that we've got. And so my project is, sorry again, Andres, but it's a CDK project. And what it does is it's going to build us an API gateway. Let's see if I can find, where's my main stack? Where is my main stack? There it is. So my main stack is going to create a VPC. It's going to create an ECS cluster. And if we look at our ECS cluster, it's pretty straightforward. It's just going to create a basic cluster. We're going to call it sample cluster. And then we're going to go down here and we're going to create a load balancer. That load balancer is pretty normal. It's just an application load balancer. with a security group that's allowing some traffic. Do notice here, which we'll look at just briefly, this is in a private subnet, right? So this is a private load balancer, which is kind of nice. We've got our availability zone set, and then I'm setting up target groups. So these are important because they're going to drive our blue-green strategy. And so target group A with a health check, you can see that I'm letting traffic in on port 80. And then I've got healthy codes of 200. I've got my time at intervals, nothing major there. And then I'm building a green target group. Looks exactly the same. And then I'm creating a couple of a listener here attached to it as well. And so like I mentioned in the traffic shifting, there's a test port that comes up. And so let's say that you're on blue and then you're going to shift over to green. What'll happen is that green will be hot on 8080 before traffic starts moving. So you can actually test your service kind of in a preview mode. There's lots of ways to do that, but this is an easy way to get access to it. So if we go back to our ECS deployment, we're going to create a service. Actually, no, first we're going to create this Lambda function, which we're going to hold off, and I'll get to that later at the end. And then we're going to look at this ECS service construct. And the service construct is going to build our Fargate service. It's going to, right here, set our controller to CodeDeploy, which is nice and built in for us. We're going to attach it to a network target group, which I'm attaching to our blue target group. And then we're going to go ahead and configure that we're going to go all at once. And so I've already run this stack, so I'll show you what it looks like when it's out there. So last piece, we're going to build an API gateway. So our API gateway is right here. Remember, it's a private load balancer. This is an HTTP API gateway, not a REST API gateway. So we're going to build a VPC link, and it's an ALB integration or HTTP ALB integration. And then I've defined one route. That is route 1, and it's just a get, and it's going to forward that on to our code. And all our code really does is it's going to print back to us on that route, blue or green, is really all it's going to do. And so I think I may have that code. Let's see if I have that code. Oops. I think I have it. Rust, and I think it's here. Yeah. So yeah, here it is. So all it does is it prints route 1, simply coming out. So, and then it's going to know whether or not we're on blue or on green. And what I've done ahead of time is I've already created my ECR registry. Elastic Container Registry. I have a public registry right here called Rust Blue Green, and I have my latest prints green, and this one prints blue. And all these do are the print blue is right here going to show me blue. My print green is going to just change the color to green, and we'll be able to run that from there. API gateway already deployed. Like I said, it's a simple HTTP REST endpoint, HTTP gateway. It's got a VPC link set up for it. You can see our sample VPC link targets the VPC, and we're going to have just a route. And so let's go look at our stages and default, and then here's our endpoint. So let's grab this endpoint, and let's just go look at what that does. Right? Yep. And if I was to run this, I left off the 1. Cool. So right there, route 1 from green. And that's essentially, let's drill into the cluster. And here's my sample cluster that I created. And here's my one service. My one service has one task. If you look at, here's our listener that we configured in our sample load balancer. We'll go look at the load balancer too here in a second. And here's my one task that's running right here. And my one task is pretty basic. It's just a simple task listing over port 3000 and nothing real fancy inside the actual task definition at all. So the load balancer is also, let's go look at the sample cluster ALB. We've got 2 listener rules, port 8080 and port How many mouse clicks? That's funny. It's only when I'm in the browser, Andres. So we have 80 and 80, and you can see right here we've got two uh, target groups or forwarding onto. We can look at our rule, and right now we're pointing specifically on blue. I got my task confused because you can see I'm routing from green, like I said, even though it's pointing at the target group of blue. Last piece to look at is this code deployment. And so what gets created for us is we get an application. So when we attach, let's go back over here. When we attach, oops, when we attach this service right here and tell it that it's going to be a code deployment controller. This creates this application, which then creates this deployment group. And this deployment group is going to have our group name, our application name, compute platform, the service role that I define it, the deployment configuration, environment, right? Here's the ECS cluster. Here's the ECS service name. Here's the load balancing setup, right? You can see TG1 is blue, TG2 is green. Code deploy keeps track of all of that. David did. I did actually just copy that with a mouse. And so triggers, these are things that could automatically roll into it. And here's our alarms. They've got set up, and then some more tags and things of that nature. Deployment configurations. These are ones that AWS builds for you, which is super cool. So code deploy default once at a time. This is ET. You run EC2. You can run EC2 on premise, which is kind of fun. Here's one of the Lambda ones. So if I look at ECS, we'll see ECS all at once. ECS linear, 10% every 1 minute. That's kind of fun. And then I actually created one that we'll use here, this custom, that was the 20% at 1 minute that we have right now. So the last piece I want to look at is, before we get going, if I go look at deployment applications, we'll go into deployments. And if you look at this history, so we'll see all these live. We'll actually run this. Step 2, step 3, step 4. The deployment lifecycle. So here were these hooks that I was talking about, right? And here are the individual pieces and parts that are actually happening. And so what's kind of fun about this is, if you were interested in automating before traffic or at any point, right? So like, let's say I wanted to before allow traffic, or, after allow test traffic, or after install, or wherever I wanted to run this, and I wanted to do something with that, I could build me a Lambda that executes on any of those hooks. And so I've got one, and we'll take a quick look at it. You can see that I've run it one time or a couple times, but all it does is, and let's take a gander at the source, which, by the way, it is more Rust. I know, sorry. But what it does is that when the function handler runs, it's going to take an event, and this Lambda event, right now it's just this hash map of string. It's actually a JSON payload that gives you a deployment ID and a lifecycle event ID. So this deployment ID is really important because it helps you, which I just noticed you can't see. Now I can see. Look at that, Andres. I'm improving my live streaming capabilities. So the deployment ID is important because, back to this, nobody stopped me. I should have been paying attention as a much better host. This deployment ID is the actual deployment that's running, and we're going to get a lifecycle execution hook ID. And all that this is doing is, in this case, I'm running a test, and this one test that I'm running is executing a request, which it's running the one route. It's running that one route that I have, and it's just checking whether it was successful. It's a really pointless test, and it's actually not even a very good test. But the example is that you could have complex tests that you want to run that could be attached to your container or to your feature, right? and you could run these things in a way that before traffic even gets out to your canary or to your linear, you could exercise what that looks like. And it's super powerful. I mean, it is more code to keep track of, but if you're really trying to, minimize your blast radius, so to speak, with a Fargate container, you could let like 1% of your traffic out, which would be fine. Um, uh, Yes, it does. It just makes a web request and you're going to get the payload back and then you can do whatever you want to it. So let's say I was running like my one endpoint started throwing exceptions. I could trap that exception. And then what I do is down here is before I even, or when I put lifecycle event, I can put this as failed or a success. And so if I send anything other than success back, right? So right up here, there's the succeeded and failed. If I send back failed, the deployment's off and everything's done at that point. So these are kind of cool because again, you can jump into any of these lifecycle hooks that that you want during the process of executing this. So, okay, what would it look like if we wanted to deploy? So let's go take a look at task definitions. So I have a simple task definition that is this Rust blue green, and I've got 3 versions. I created them ahead of time. I cheated, sorry. And I think, what are we running on right now? Let's look and see what the current version is. I missed the music, Andres. We really need like live stream, like filler music. So we're on task 3. So task 3, if we take a look at it, and let's go look at the JSON definition. It's running on latest. Okay, well, that's pretty crappy, Ben. Why did I do that? Latest is actually printing green, if I'm not mistaken. If we go back and look at our, wasn't it? Yeah, route 1 from green. So we're running green. What we're going to do now is we're going to go back and we're going to look at and deploy version 2. Because version 2's already got this. Obviously should be a rolling type thing, but for demonstrate purposes, version 2 is running print blue. So as you can imagine, version 2 is just going to print blue instead of printing green. And that's what we're going to do. So let's go out here to deployment. Simple way to do this. Again, a lot of this would be automated. It would be in a CI/CD pipeline. If you're using Code Pipeline, there's obviously really good integration for that, which I would recommend you do. If you're not using Code Pipeline and using like something like GitHub Actions or Azure DevOps, something along those lines, running the AWS CLI and executing a code deploy is just as good. So we'll copy a deployment. Let's walk through some settings. So we can specify the deployment group, which we looked at earlier: compute platforms, ECS, blue green, managed hook. This is we were going to run in these, but we're not going to do that today. My applications. This is the app spec editor. This is what we're going to go look at in a second. And so we're going to do YAML. Whatever my source is. Deployment description, we can do that. And then you've got deployment overrides. So back to our deployment configurations. For this example, we're going to do my custom one, right? We're going to do the 20% over 1 minute. So what that means is it's going to shift 20% of our traffic in that right at the initial, and then it's going to wait 1 minute, and then it's going to shift the 80% at the tail end of that. And then rollback overrides. So we can roll back if alarm threshold remits, roll back when deployment fails, and all those things. The other piece that's not in here that is back further up in the deployment group, which would be if we wanted to pick a different deployment group, that's where you can set things like how long tasks hang around for and that sort of thing. I'm pretty sure in my case, if we look at the deployment group, I think there it is, Andres. I love it. There's the music. I feel better now. These deployment groups are where rollbacks and stuff are kept. So we can look at what that means to create a new deployment group real quick. Roles, cluster name, load balancer, all this stuff. And then we can all at once. And then original revision termination. How long do you want to hold on task for, right? So we can hold them on for up to 1 hour, 1 day, and 23 hours and 55 minutes. Sorry. Can't even make it 59. Can't even get to 1 day and 23 hours and 59 minutes. So anyway, so that's kind of fun, but we'll go back out of that for now. Now, running this file, we'll jump back over, and what we're going to do is let's shrink that up. Oop. And I want to look at this app spec file. So what is this app spec file? It's a YAML or JSON file that specifies the target service. This is all documented out on the AWS documentation. But it specifies the type of service, which could be Lambda, but in our case, it's ECS service. We're going to give it a task definition, right? So don't steal my account ID, but there's my account ID, Rust, blue, green, and there's an ID on the end of it, and we'll copy that over. Load balancer info. So container name, where does that come from? Let's go take a look. So the container name comes from right here, container name on the task. And container port, as you can guess, is going to come right off the container port. There it is, 3000. So very important to keep those together. And here's our Lambda hooks. And it's as simple as giving an ARN. And we'll delete these because they're not important. And so if you look here, just a Lambda ARN, and this matches back with the function ARN that I had somewhere buried in all of these Firefox tabs right here. So Mike Hotel 03, Mike Hotel 03, right there in the end. Or there we go. All right, so let's grab all of this file because we're going to need it. And we're going to grab some file. And then we're going to go over here to our deployment. And we're going to set this. So, but before I set it, I have a value I need to plug in. So we're going to do task 2 instead of task 3 because we want to roll with blue. Oh, it looks pretty good. And we'll just do for the biz. I can't call it biz anymore. Believe in serverless demo task. And why can't I call it biz anymore? It's an inside joke. It's yeah. So believe in serverless. So, okay, we're going to create a new deployment and off it's going to go. So what's happening right now? We'll look at this in like 2 or 3 places. So this thing is running. It's deploying the new task set. So, oh, there we go. CodeDeploy or Fargate or ECS, I should say, one of those services has recognized that I'm doing a deployment and it's in progress. The other thing that may or may not have any traffic yet, let's see if our load balancer. Nope, it's still on sample cluster blue. All right, so we're going to watch this a little bit. And what's happening is the task is getting deployed. And what does that mean? Well, Fargate's launching, or ECS has launched us a new task, right? Running task number 2. So now it's going out there side by side with task number 3, and they're gonna get into the octagon together. And what I'm expecting to happen right now is if I was to do this, is we're going to curl that. I'm still getting green, right? Still getting my green traffic, which is kind of good. That's what I would expect. And CodeDeploy has not done anything yet with traffic shifting. It's still deploying the task. And I'm impatient, so I'm going to click the button a couple of times to see what happens. I'm going to check my private chat. Oh, Andra said zoom in a bit. Thanks for reminding me. I appreciate that. Still deploying. I feel like this wait music is really important at this stage of the presentation. Oh, there we go. Test traffic setup. So looks like we've got some test traffic and now we're rerouting. So we've already moved 20%. So there's our canary, right? And let's go take a look and see what's happening out over here. So I've got green, oops, green. Oh, now I've got one from blue, but I'm back on green. And now I'm on green. It's kind of a fun game, right? So let's run that again and see what we get. Cool. Route 1 from blue. So what's actually happening right now while this traffic is shifting, this listener, if you look at our target groups are split 80-20, and our service is now going to be split as well. So here's that going. This is still, I don't know why this one's not kept up to date, but whatever. But it's nice to see that our traffic is, oh, and it looks like our traffic's all the way back over because we only waited 1 minute. So we were getting from blue. Now we should be blue all the time. Oop, still killing the greens, looks like. A little bit of residual. Code deploy might have been a little bit too aggressive. But as you can see now, we're getting nothing but blues, right? Which is interesting and what we'd expected. So what was the, we had our Lambda. And if you see, we had the test traffic route set up. That's kind of nice. And then we have before install, after install. We did have a Lambda, if you remember, defined in our hook. And what did that do? So let's see. So we have our Lambda that's sitting out here. What did that mean? So our Lambda would have run and triggered, which means we should have got some logs. Let's go out here and take a peek at our CloudWatch logs and see what all happened. We got a log stream, which is great. Looks like we had one 1739, which would have been, yep, about 2 minutes ago. And looks like we got some messages that said internal cluster hit route 1. I hit route 2. There's more routes inside of that. And then here's route 3, and then on and on and on, and wrapping up the very end with succeeded. So we've got a code deploy that has rolled out our traffic, which is pretty fantastic. So let's do that again and kind of let's see what happens in the scenario of failure if we wanted to simulate a failure. So go back to our listener real quick, and you should see, yep, 100% on green now. What we're going to do is we're going to go out here. We're going to grab our configuration again. Oops. And we're going to grab all of this, and we're going to copy it. We're going to take it back out to our code deploy. So we're going to copy our deployment, and I'm going to use my AppSec editor again. And I'm going to go task. We'll go back to 3. So we're going to try to go back to blue. And I have a feeling that we're going to break this on purpose. So let's do a Canary 10%, 15 minutes, just to give us a little window, because I'm going to cancel it anyway. So if we trigger this deploy, and again, I didn't even run this with Lambda, but now we're going to go after this first initial set. So we should still be getting our blue traffic, which is what I would expected. And we're going to let this go out and deploy and see where we go. Kind of excited nothing's blown up yet, but I probably should knock on wood. What's this music? This is very soothing. All right, so we're out rolling some traffic, getting close to having this all ready to go. Should come pretty fast now. Let's see, we're almost there. I do like the graphics though. It's a nice UI. I'm getting word that this is Suno magic. Feels like magic, the music is. Come on, you can do it. A little bit more. Need some traffic. Still no traffic. We're going to get some, don't worry. I promise. As soon as I go over here and look at the tasks, I'm pretty sure it's going to be like, I'm ready and I'm up. Yep, listening, of course. There we go. So now I've rerouted. I got 10%. Okay, so I should see some green mixed in here, which I would expect some green. There's blue, 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 blue. You would expect 1 in 10, but you all know that load balancers don't quite work that way. So we're going to get, there we go. We got a green. Great. Oh, another blue and blue. And let's just say that for some reason, I'm running this and I start to discover an error, right? And I don't like the way this is looking. So again, I'm going to go take a look at, I got 90-10 going right now. Remember, this is going to hold for 15 minutes. I think that's the one we did. And it's going to sit here and we could be getting bombed. And so, and paying with a bunch of errors and whatnot. And so if you had a CloudWatcher alarm, which is what I'm going to simulate, I'm just going to go ahead and stop and roll back deployment. And so if I did this manually, it's going to warn me, or incomplete deployment, roll it back, stop the deployment, redeploy the last successful. So we're going to stop and roll it back. And it's in the process, rerouting traffic. And it's already done. We've rerouted traffic, and we're getting blue again. All blue all the time. And all the load balancers back, deployment rolled back, and the ECS deployment should show us. We shouldn't even have tasks anymore. Yeah, those tasks are already, that task is already gone. And we may even see, yep, stop, there was our green that didn't make it. So you can see it happens pretty quickly. So if something was going wrong and you had a CloudWatch alarm and you were worried about safety, you'd get a pretty quick rollback in the scenario that you were concerned. So that's where I'm going to stop. So I don't know how many people we have on, but I am happy to take questions or whatever else. But I hope this was meaningful to you all to take a look at.
Hello, Ben.
Hey, who's there?
I was sneaking in the backstage.
You lurking?
Yeah, of course.
We're wearing your community builder hat. I like it. Look at that. That's so fancy.
So, good stuff. We do have one question from David, always with good questions, and I popped it on the screen. So when you're doing this with Lambda, it works similarly, right?
What do you mean by that? I can't tell that that's David because like that's like young David, it looks like.
So what I think is the setup and kind of the process, is it similar? I had a similar question, right? Is it different than ECS? No. Is it more or less complicated, right?
Oh, with Lambda. Tooling? Yeah. So no, not much different at all. You're instead passing a Lambda, you're using Lambda versions, right? Which are just pointers to things. So instead of doing like, Docker tags, you're using Lambda versions. Which is pretty nice. And you can do the same kind of stuff, right? So if I go back and show you the where we are. Yeah, sure. That screen. That's great. We go back and look at this deployment configurations and we look at Lambda. You've got two, right, that are defined, right? So you can go, this is the linear 10% over 1 minute. Or you could do the same thing. You can create your own, right? So you could build a deployment that's like Canary or whatever it is that you wanted, and it just works with Lambda versions. And you can also test and handle hooks and all that stuff just like you would. Which is great. Yeah, it's fun. Like, and again, like I feel like Lambda blue greens are that feature that nobody uses because you're like, it's just a Lambda, it'll be fine.
Yeah, what I've seen when enabling versions for Lambda, you kind of enter a different little world in Lambda in maintenance and maintainability of that. So
it's right. You need aliases. Yeah.
David says you're giving that Bob Ross vibe with this music, so that's pretty good.
I have happy containers.
Next time you're going to be drawing in the back and you're going to turn that into a whiteboard.
Happy containers. I feel like I could make a thing out of that. Like whiteboarding with Ben and Zen music might be a new.
So Ziad is confirming it requires aliases for sure.
Which I mean, like Lambda gets a little squirrely. It can be tough. And they even work a little different than step function versions, right? To me, it gets a little squirrely, but happy little coding accidents. That would be great. That'd be fantastic. I just show up on Friday. You'll see Andres and I do that on Fridays.
Lots and lots of accidents.
No, so I hope this was cool. Like this, like I said, I use this a lot, this pattern. Because I like containers.
It's cool to see it in action, right? So like actually seeing you hitting API endpoints and seeing them shift to the new one and then backtracking, right? That's the live and kind of that warm and fuzzy feeling you get of protecting yourself.
Yeah, and so the couple of gotchas. So to do this with load balancers, you've got to use an ALB. You can use an NLB, but NLB only supports all at once. NLB won't support linear or canary. At least it didn't as of like a month ago, and I haven't seen on Luke's AWS news that came out recently. But so that's kind of the one gotcha in that regard. And then again, the target group, like there's so many things in Amazon that are soft limits. The target group max on an ALB of 100 is, again, best of what I remember from like a month ago, it was like a hard limit. So you kind of are limited to 49 services per ALB, which is a ridiculously large amount if you think about 49 services under one load balancer. That's quite a bit. And
does all of this tie well? I mean, because I've seen people use like feature flags, right? You can do this sort of canary deployment, right? It's already deployed. You're just shifting traffic with an if in your code. But is there a way to like tie in app config feature flags to this blue-green deployment that you're doing, or it requires more effort on your end to build that
more
system?
Effort. Yeah, it's going to be more effort. The other thing that's kind of interesting is if you've ever done like database migrations and you've had to think about like, you almost are playing chess with yourself. You're thinking a move or two ahead. Blue-green's kind of the same thing, right? Because let's say that I'm going to roll out version 2 while version 1's running. Well, version 2 has to be backwards compatible with my UI and everything else, right? Or else like I've created all kinds of problems. So it's kind of, that's why I think a lot of people end up with, I have a pet squirrel that are close to it, David, that I can bring in here. She looks like a squirrel. But so, like you can get yourself in trouble if you're not paying attention to those versions.
Yeah, backwards compatibility is tricky, right? Or you have to version the backend to then shit, and again you get into backward compatibility is usually the best, easier route.
Like if you're talking about like real, I mean, and then a lot of times I think people get confused. They want A/B testing versus really like you really don't A/B your backend a lot. You could, but really what you're talking about is A/B front end testing, right? And then that's better suited with CloudFront, right? And Route 53 perhaps. It's better up front.
You bring up a good point, right? You're doing more of a network kind of blue-green deployment, right? So you're completely rerouting to a different instance for a blue-green or A/B testing, right? That you're doing user interface stuff sometimes. That might actually be easier with feature flags, right? And you turn it on for a specific user and stuff like that. But this brings up a good question. In this blue-green deployment, you're setting the percentages. Is that about it? Can you set up more complex rules as far as how it distributes the load?
Not really. I mean, I'll go back to sharing. And that's kind of the beauty and the downside to some of this, right? Is that you're stuck with AWS defaults in a lot of cases, and they can be a little limited just because they have to be in a lot of cases, right? So if we look at, your AOB is, I hate how mine comes up, Lightsail X. I'm using Lightsail in this account it's where my blog's hosted. And so you've got rules, right? And your rules are very much, this is just the default rule. I don't know why I'm lucky. I should have been peppered with all kinds of things. I didn't go do that and disturb that entire time. You can add listener rules. And so let's add a rule, right? and your rules are pretty limited in what you can do, for the standpoint that your conditions are going to be limited to these options, right? So it's like if you wanted to, you could maybe get a little bit trickier. I think you can have 5 rules per target group, pointing at it. So maybe you could get a little bit more clever, but yeah, I mean, not really. Like you can't be like, hey, I want to route, unless you're passing it in a header, right? I want to route this traffic to this based upon that. I mean, you could get a little bit more complex, I guess is what I'm saying. But it's not like if you were just running your own version of like Nginx, where you can do all kinds of interesting things.
Cool. Okay, that makes sense. And
you got me off track. I was down a rabbit hole thinking about squirrels and happy coding accidents.
Ooh, squirrel! You're like a dog. We're like dogs. We need a dog collar to
need a collar for this too.
Cool. Awesome. So no questions, just comments. So yeah, that sleep tattoo is drawn on using a marker. Not much older.
David's just beautiful.
Yeah. And Craigmont says, whenever I hear blue green, I can't help but think of the magic deck I built in middle school.
Yeah. Well, awesome. I hope this was good. Like I said, I like this one. This is super practical. It's simple. It's got limitations, but it's also nice because it is simple and it works and it gives me what I want, which is safety in my deployments and automatically integrated stuff with all my other AWS goodness. And it's mostly serverless, but some not. And like I've said a bunch of times, it's great if you can be serverless always, but most of the places I've worked in are serverless at best most of the time. There's always a load balancer somewhere, and there's always a SQL Server database.
Yep. Usually, yes.
There's one in there somewhere. So anyway, thanks for having me.
Well, appreciate your time on showing us Benjamin Scroll Pile. Look at that.
Who renamed that? Did you do that?
Do you want to kind of promo our talk for Thursday?
Yeah, so I'm really excited about Thursday. I'm nerding out for Thursdays. So David is going to come talk. So David's the maintainer on the Rust Lambda runtime at AWS. Also has contributed a bunch of stuff on AWS Lambda events in the Rust ecosystem, a whole bunch of stuff. So he's the primary guy. And so he's going to come talk to us about how the AWS Rust runtime, Lambda runtime takes over and how it deals with communicating with the Lambda API and all those different pieces so that your Rust code looks as simple as it does. Yeah, which is fantastic. So he's a great speaker and excited to see him on Thursday.
Cool.
We have a bunch of stuff going on.
Yeah, a lot of things going on. Friday, Ben and I are probably going to keep going with our live streams.
What were we doing? What were we doing on last Friday? What are we doing this? It's
we were in Flex TV, so
there we go. We
still fine tuning what we want to do, but we might dig deeper into Influx DB and get a little bit more done.
I like it. Awesome.
Cool.
Well, you guys have a great day.
Everybody, thanks for joining us. Talk to you later.